Hi, today we are going to be putting together a battery pack using 18650 cells and a solderless connector kit from Vruzend. I think that's how you pronounce it. Anyway, the kit has little plastic caps, nickel buzz bars, and little nickel connectors that can screw on, and then you solder your wire on. That's the only bit of soldering you'll need to do. Lots of little nuts. So I would suggest that you also need a nut spinner. I say I have lots of sets, so I have this. I'm not sponsored by Vruzend. I have purchased all of these kits. I'm just showing yourselves because I think they are absolutely brilliant. Basically, first of all, these are quite high energy density, which basically means if you short circuit them, they can go pop. No doubt you've seen the videos of vapors who have kept batteries in their pockets with their keys, and they've shorted out and gone bang. Generally, they are down to people using incredibly cheap cells or just being stupid and having keys in their pockets with batteries. So Darwin Awards, perfect contenders. Basically, to make a battery, these are 3.6 volts nominal. So to make a 36 volt battery, you need 10 cells. And when you connect 10 cells together and you add their voltages together, that's done when the cells are in series. So this is an example of the kit clipped together, and this is a 10S, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 4p, 1, 2, 3, 4. And because batteries have a top and a bottom, you need a bank for the bottom and a bank for the top. So, moving on. Whenever you're working with batteries, try and be organised, and don't mix things like metal tools with your box of batteries. Let's just get some caps out. The first thing you do is you have to connect the caps up. Now this is as easy, well, it's easier than working with Lego, because despite the fact they're different colours, they're actually the same. So you have female slots and you have male pins. All you have to do is, I like to start with making the top row, is to make sure that they're the same way round. So in other words, if I use a red cap in that direction, then when I slot the blue cap in, which is a lot easier if you're not doing it to camera, then the top has, in this case, the male pins poking up, and then you simply keep adding. Now, I do the series connections first. Technically, there's nothing wrong if you do the parallels first, but I just find this is the way my brain works. So let me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. Now, as I said, that's a series. So if I was to just use a single cell, so if I just pull out 10 cells, right, and positive, negative. Now, obviously, I don't want to be shorting out any cells. So if I was to carry on putting cells down, and obviously I'd have made another row, these would be clipped together, then that would be a 10S 1P, so 10 in series, 1 parallel. I'll put that to the top. 2, 3, 4, 5, 1, 2, 3, 5. Right. So what I'm going to do is I'm going to make another row and show you how easy they are to clip together. But because the next row will need to slot in, then I'm going to put the slots down, have a slot down. And again, identical to the way we did it before. Except I'm just, it's easier if you put them on there, put them face down, and then you can just slot them in. Like this. And I say, I mean, it is very easy, but it's even easier if you're not thinking about the camera and you make silly mistakes like that. You're just pushing them in. So, hardly any force required. Right. Now, to join, if I was to make a 10S, so 36 volt, but I wanted to have more cells in parallel, then I'd simply get another one and link the two together. I don't know how well you can see that, but basically all the male pins, all female slots. So we just line it up and push in like that. Now what we can do, cork, so nice and soft, cork, and then just gently tap that into place, like so. Now, the reason why you do this is if, for example, these cells are 2.2 ampere hour, so that wouldn't make a very big battery pack. So if I was to have two like this, then I would add the 2.2 and the 2.2 together to make 4.4. This pack, so 10S, which is 36 volt, and then I add 2.2, 2.2, 2.2, 2.2. So 4 times 2.2 is 8.8. And you can keep going and going and going. For example, here's one I made earlier, which is the top and the bottom plate for a 14S, so 52 volt, and that's 8p, or 8 in parallel. So that's the 8 times the 2.2, which is 17.6 ampere hour. So this will be a reasonable size battery. I could make even bigger ones. One thing you do need to think about is all of your cells that you use within a battery have to be the same. If they're not the same, then you can get all sorts of balance problems. So for this example, I won't bore you just by putting together lots of little bits of plastic, because if you're watching this video, then I'm sure you can figure that out by yourself. Here's two I prepared earlier in the best Blue Peter fashion. Now, there is a small number of the cells that I'm actually going to be using. But for this one, I obviously won't be using all of them. Now, before you make a battery, then you have to charge all of the batteries, all of the cells up, so that there's the same voltage. So positive goes into red. So basically, if you've got a red cap, you put positives in. If you've got a blue cap, you put the negatives. And so on and so forth. This will obviously require 40 cells in total. But to make this video as brief but informative as I can, I'm not going to put all the cells in. So I'm going to ask you to use your imaginations. Now, so imagine I've got the bottom plate, all the cells, and this is the top plate. I'd start with the top plate. Now, the first thing you do is make the parallel connections. So, as you can see, these fit over there quite nicely. Oop. I'm just going to this screw here is slightly out of line. What I'm going to do is very gently move that. Now, I'm not bending the screw, because on the underside you can see the metal contacts. So See, turning it upside down, not my greatest moment. These go over nice and easy. As you can see. Right. I'm not going to carry on all the way. Right, so after you've done your parallels, and your parallels will come all the way down, you then put your series. You missed the first row out, okay? So your series just go across like that. I have to put that down now to quickly work on this. So if you move the pins back into the screw threads back into position, then you only use a very light amount of force because you're just gently guiding. So that's the pattern that you need anyway. So you join these in series, these in series, these in series, these in series. Right. You then take some screws. Now, one of the things you're going to need to do is obviously have power in and power out. This is the top, as I've said. So you need to use one of these ones, and they again slot in like that, over two, and that will become our positive. Nut driver. You don't need to over tighten these, but obviously you don't want to under tighten them either. And that's how easy that is. For reference, the nuts are 5.5 millimeters, so 5.5 box. They're available just about everywhere, and it will save you hours. So again, I'm not going to do the lot because you'll just be sitting there watching me screw a load of little screws onto little threads. Not really interesting or relevant. The underside, we would start the underside off in series. Well, we do the parallel connections first, but then the series connections would start there. So just imagine all the parallels are done. So remember, all the parallels will be done here. So working backwards, well, no, electrons flow from positive to negative, I believe, but don't quote me. Anyway, so if this is the underside, then you'll go positive, negative, but the negative will be attached to this positive. So the electricity will flow from there to here, then across using this series connection, series connector, then come up to here, then across this series connector to the blue. So as you can see, it will zigzag its way down the pack. Right. A BMS will be required on anything more than a 1S pack, and I will cover the BMS wiring after I've actually finished building the pack, and I'll show that on a different video because it's a slightly different discipline. This was purely on how to the basics on how to build the Vruzend kits. Again, as I said, and as you can see, you're not having to spot weld any batteries. All you need to be able to do is put some little bits of plastic together, stick some metal bars across that are in a set pattern. Again, you can draw it out first if you'd want a drawing to work to, but basically you're just making figure of eight, figure of eight, figure of eight. Again, we're using the top here, so that will be the positive end of the battery. This will be the negative side of the battery. So if I get another like that, feel free to ask me any questions. I will do my best to get back to you as soon as I can. And yeah, I will be covering battery management systems in another video, and I will have a fully built battery with all the cells in, so you can see what the deal is there. Few things to note when you're using these kits. They have been designed pretty well. Obviously, don't use a metal workbench. Don't have bits of metal lying around. This is a poor example, but again, I've got my cells well out of the way. And if we get another mat, you'll be able to see that they've been designed so these legs are longer than the metal terminal. So even if you were working on a metal bench, which would be dumb, then the pins shouldn't ground out. Obviously, if you're making a big battery with lots of capacity, then you can get arcing. So work on an insulated surface, say wood, and I'm using cork here. The kits are not dirt cheap, but they are well built. They are reusable. So once you've, if you decided, oh, I've got no use for a 10S battery anymore, a 36 volt battery, I want a 48 volt battery, then you can, with a bit of persuasion, say these things are never going to fall apart on you. But you can take them apart and if you take them apart one at a time, then you're not going to overstress anything, and it really is as simple as that.